More chain rule. So this starts at K because it just follows what we did on Friday where we stopped. I'm pretty sure we probably ended with J. So this says, some problems require product rule or quotient rule as well as the chain rule. So all we did on Friday and all we did on our little warm-up was just purely chain rule. But if you look here, this definitely is a product. That one example we did, this was a number, not a variable, so we wouldn't necessarily have to think of it as a product. This is totally a product, so we have to use the product rule. Okay? Product rule starts with what? Okay, so let's do that. Derivative of the first, so the derivative of x squared is 2x. We multiply that by the second, 2x minus 4 cubed. We don't do anything to it, right? Because we took the derivative of the first times the second. Then is it plus or minus? Plus. Then what? The first, okay, times the derivative of the second. And what do we have to do when we do the derivative of the second? Chain rule. Okay, so it's x squared times, so I'm going to have 3 comes out front, right? So 3, I'm going to put that in parentheses just so I can figure what's going on here, times 2x minus 4 to the what power? Second. So this part right here, that's the first part of my chain rule where I take care of the outside. Then I have to take the derivative of the inside, which is what? 2. Okay. Everybody good so far? That's a safe stop. That shows that you know to use product and chain rule together. But if we want to clean this up, I'm going to make this 2x times 2x minus 4 cubed. So we'll multiply the 2, the 3, and the x squared together to get plus 6x squared times 2x minus 4 squared. Now, let's figure out what our GCF is here. Okay, 2. What else? 2x. I can actually use 2x, right? Notice we have, so this is one term, this is another term. So yes, they both have a 2x in common. They also have 2x minus 4 squared in common. Look at that. We got that? So if I factor out the 2x, so I have a 2x, I'm also going to take out the 2x minus 4 squared. Here's what we're left with. So I divided out this 2x, and I divided out 2x minus 4 squared, so that leaves me with a 2x minus 4 plus, I divided out the 2x, so here that leaves me with 3x, yes? And then I divided all of those out like so. Okay. Everybody understand where everything came from? Because, yeah, we had a safe stop. Even the second one would be a safe stop, but we're not finished yet, and this could totally be a multiple choice answer. But does everybody understand where everything came from at this point? I factored that out. So then now, this is 2x. I'm just rewriting this first part. 2x minus 4 squared. I have these parentheses, but since it's to the first power, that doesn't really do anything, right? So I have 2x plus 3x. That's 5x minus 4. And that is my dy dx. So on a multiple choice question, yes, you have to be able to take the derivative, but then you also have to be able to manipulate the algebra to make it look like, to kind of simplify it all together. Sometimes, but sometimes not. Ask me a question. All right. So I'll say this again. Everybody okay with how we got here? All right, so then we look for our GCF. Out of these two terms right here, two big terms, they both have a 2x in them, all right? They also both have 2x minus 4, right? But they have 2x minus 4 squared is what they share. That's why I factored these out. That's my GCF. When I divide that out of this first term right here, the 2x gets totally divided out here, and then this 2x minus 4 squared, I'm just left with this 2x minus 4. In the second term, when I take the 2x out, that leaves me with the 3x. and I took all of the 2x minus 4 squared out. So it leaves me with that. And then I just combine like terms here to get there. Okay? So your GCF can be more than one term. That might not be something that, you've seen very often, but it happens. You've got to be able to make it make sense. We good? Okay. So let's look at the next one, L. So do I have quotient rule here? Yes. Do I have chain rule? Yes. Do I have product rule? No. Okay. So, but I do have the quotient rule and I have the chain rule. What do I start with, chain or quotient? If you do chain rule, do you work from the outside in or the inside out? Outside in. So since this 4 is on the outside, I have to do that first. Okay, does that make sense? I have to start from the outside in. So my derivative, okay. No, you do not. No, and we'll do one of those and I'll show you what it looks like. That's a good question. That's a good question. All right, so we're going to start from the outside in. 4 times x over x plus 3 to the third power, right? So chain rule says we do the candy shell first, then we do the inside. So the inside is going to require quotient rule. Do we agree with that? I'll take that as a yes. So quotient rule says, that's what I'm doing. Okay. So yes, to answer that question. So I did this, and then I have to take the derivative of the inside and multiply it by that. So to do the derivative of the inside, I have to do the quotient. Okay? That's a good question. Does that make sense to everybody while we're doing that? Okay. So we know we're going to have a fraction. So quotient rule says I do the derivative of the first one, so that's just 1. I'm going to write it down even though it's a 1 so I don't get lost in anything, times the derivative of the derivative of the first one times the second one, x plus 3. Then what comes next? Plus or minus? Minus the first, which is x, times the derivative of the second, or the denominator, which is 1, all over what? X plus 3 squared. Okay, so make sure you understand where everything came from. Everybody good with that? Okay, so now since I have 2 fractions and the 4 is not a fraction, I'm going to make the 4 into a fraction so I don't lose anybody anywhere. So I'll make that 4 over 1. Remember when you were, this is a total side note over here. If I had 4/5 and I squared it, what is 4/5 squared? Okay, because I could rewrite this as 4 squared over 5 squared. Do you agree with that? Like that's basically what you're doing. So that's what we're going to do with this right here so that we can combine all this stuff together. We're going to take this that's x over x plus 3 cubed, and we're going to make this into x cubed over x plus 3 cubed. That's the same thing. Okay? I don't get to distribute the cube to every single little thing in there, but I can put it in the numerator and denominator and split it up like that. Everybody okay with that? So then I'm going to multiply by this next fraction, which in the denominator I know is x plus 3 squared. In the numerator, these ones kind of just take care of themselves. So I really have x plus 3 minus x, which just leaves me with 3. So step 1 here, this was a safe stop. This is also a safe stop. But again, we have to have the skills to be able to actually put it all together. So then we can say dy dx equals, so in the numerator, I'm just multiplying fractions is easy. We just multiply straight across, right? So in the numerator, I get 12x cubed. What would I get in the denominator? X plus 3 to the what? To the 5th. Yes, because if I had y cubed times y squared, that becomes y to the 5th, right? So I have this cubed times this squared. These are the same. The bases are the same. So you add the exponents, and this is what you get right here. And that's your simplified answer. Ask me a question. What is going on over there? Everybody good? Okay, so I see you stare. I see some of y'all looking up here, and I see your little wheels turning, and you're processing it. If you're processing it, it doesn't make any sense. Say something now. If I lost you somewhere, speak up. Okay, whatever. I'm going to assume that you get it then. Okay, so the difference between, okay, listen. Shh. Here I did product, then I did chain. Here I did chain, and then I did quotient. The difference is this cubed isn't outside of the entire thing. If I'd have had, so this is not the question, but if it was something like x squared times 2x minus 4 cubed, like that. I mean, I could also distribute that, but whatever. You know, I could do the chain, start with the chain, and then do the product inside. Okay? But with like whatever's on the outside, I have two things multiplied together. That's how I know to start with product. Okay? Here I have a quotient, but quotient's inside, and I always work from the outside in. Okay? So that's a very good question. And that's not the question. Because it's not an always you start with this. It depends on the question, right? All right, good. Anything else? Yes, ma'am. Okay. Uh-huh. Uh-huh. Yes. So do you understand how I got these three fractions? Do you understand where these? This one is just this simplified. So it's this in the denominator, and then this just all becomes just 3. Okay. So then, yes, I multiplied all three of them together to get to this. 4 times x cubed times 3, that gives me 12. And then, remember, if this was y cubed times y squared, that would give me y to the 5th, right? And so basically that's what this is. This is y cubed, y squared, so you get this to the 5th power. Good questions. Anything else? Don't be afraid to speak up or ask me to repeat it. Okay. Now let's look at the next one. So do I have a quotient? No. Do I have a product? Yes. Do I have a function within another function? Okay. So, yes. So this is, so e to the x, excuse me. E to the x is a function, but instead of x, I have this. That's the composition. So my polynomial is inside my e function, right? Make sense? So I have a chain, but the chain goes with this, and this is a product. So I do the product rule first, okay? All right, so product rule first. Here we go. We're going to take the derivative of the first, which is 2x, times the second, which is e to the 3x cubed plus 2x minus 1. I took the derivative of the first one. I just rewrote the second one. That's the way the product rule. Do what? A lot. Not everything. Okay. E's not nearly as difficult. E, it looks weird, but it's really not as difficult. It's just new and different. All right. So then plus, I write the second one, which is x squared. And then I have to take the derivative of this second one. What is the derivative of e to the x? E to the x. And this x in this case is this. So basically I just rewrite this again. E to the 3x cubed plus 2x minus 1 power. You don't because it's all up in the exponent. If it makes you feel better, you can. But yeah, I mean, it's not wrong if you do. Let's just put it that way, okay? So the derivative of the first times the second plus the first times the derivative of the second. So I have done the outside part. I've done the e part. So now I have to take the derivative of this exponent, which is just a derivative of the polynomial, 9x squared plus 2. Okay, let's do it this way. Let's just say I have f of x, or let's call it g of x. let's call it g of x. G of x is equal to e to the 3x cubed plus 2x minus 1 power. So when I find the derivative of this one, chain rule, okay? If you have an e or a natural log, you have to do the chain rule. So the derivative of e to the x is just e to the x. So I just rewrite e to the 3x cubed plus 2x minus 1 power. Then, chain rule, now I've got to do the inside part. This is the inside part. The derivative of that is 9x squared plus 2. But I don't multiply it by the numerator. So that's what I did right here. I just went off and did that separately so I didn't lose anybody else. Everybody good so far? All right. So now, let's look at Gcfs. Oh my God. How many terms do I have? Depends on how you look at it. I got 2 inside of here, but I have 2 big terms that are being added from my product rule. Okay? In those 2 big terms, I could factor out or divide out. I can't divide out a 2. Yeah, that has a 2 in it, but it doesn't count. I can divide out an x. We agree with that? X. I can also divide out an e to the 3x cubed plus 2x minus 1 power. So when I divide that out, I would get rid of the x and this part, one of these x's and this part. So what that leaves me with, this first term, I just have a 2 left. We agree with that? Plus x times 9x squared plus 2. Then we can distribute the x. So this becomes x times e to the 3x cubed plus 2x minus 1 power times, so this would give me 9x cubed plus 2x plus 2. It's fine. It's fine. So this is kind of the fully simplified version. But this, as long as you can do what I have in orange, that's a safe stop. But again, you may have to match it to something on a multiple choice. So you got to know how to manipulate the rest of it without freaking out. Okay. Now let's look at N. Any other questions on M? All right, N. G prime of X. Do I have a quotient rule? Yes. Do I have a product rule? No. Okay, let's rewrite this. I'm going to leave it as 5x in the numerator. But I'm going to rewrite my cube root as x squared plus 5x plus 2 to the 1/3 power. You agree with that? If all I had was what's in the denominator, does that require chain rule? It does. Because you have a function, you have this x squared plus 5x minus 2 inside the cube root function. So that does require the chain rule. So we have quotient and chain rule. So the example we did at the beginning, I had just a number up at the top. I didn't have any variables, and we made this a negative exponent, okay? We can make this a negative exponent, but we're not going to. We're going to treat this as quotient rule, and then I'm going to tell you why when we're done, okay? And this one's going to get kind of ugly, but don't worry, we don't have to simplify it down all perfectly. Okay, it'll be fine. All right, so we're going to do the quotient rule. Quotient rule says we take the derivative of the first, 5, times the second, that's x squared plus 5x plus 2 to the 1/3 power. It's quotient rule, right? Minus the first, which is 5x, times the derivative of the second, or the denominator. So that's going to give me 1/3 times whatever's inside. I don't disturb that yet. X squared plus 5x plus 2 to what power? Negative 2/3, because I have to do 1/3 minus 1 gives me negative 2/3. So this is the beginning of the product rule, right? I multiplied this out here. I subtracted 1. So now I have to multiply by this derivative, 2x plus 5. All over x squared plus 5x plus 2 to the 1/3 power squared. Okay, so safe stop here, right? But we are going to take it another step or two, but not completely simplified. Here's the thing. So I'm going to tell you right now why we choose to do this with the quotient rule instead of the product rule. When you have variables in the numerator and denominator, and then you use the quotient rule, you'll end up with one fraction instead of two fractions. When it's easier to do what you want to do with it moving forward. Okay. All right. So we're going to rewrite the first. G prime of x equals 5 times x squared plus 5x plus 2 to the 1/3 power. And then minus, all right, so I'm going to have 5/3, or 5x over 3. I'm multiplying these together. Okay? Make a big old fraction here. In the numerator, I can also have 2x plus 5, because we don't want to leave negative exponents. And then the denominator there, I'd have x squared plus 5x plus 2 to the 2/3 power. So that's just the two terms in my numerator. Everybody understand where all that came from? 5/3 x. That's where this came from. This is a negative exponent, so it goes underneath, and then this 2x plus 5 stays up there. That's all over x squared plus 5x plus 2 to the 2/3 power. And then we're going to stop there on simplifying it anymore. We don't have any negative exponents. It's a fraction, and a fraction is better than a negative exponent. Okay, when we're actually trying to look at what's happening here, which we're not doing that just yet. We're just got to figure out how to get there first. Okay. What questions do you got? We good? All right. Flip it over. Let's look at how this is going to look on the AP exam. So we have the graph of function f is shown to the right. The function h is defined by this. Find the slope of the line tangent to the graph of h at a point where x equals -1. So if I want the slope, that means I need h prime. We agree with that? I have f. I don't get to, but I need h prime because I want the slope of that line. So I need to find the derivative. H prime of x equals product rule. Is it the product rule? Do I have a product here, or do I have a function and a function? I have a function and a function, which means the chain rule, right? So I do the outside first. So this is f prime of 2x squared minus x times the derivative of the inside, which is 4x minus 1. Okay, everybody understand how we know it's chain rule? You have a function inside of another function. You had gum inside the candy. So now what I want is where x equals -1, so I need h prime of -1. That's going to equal f prime of 2 times -1 squared minus a -1 times 4 times -1. I'm just substituting in a -1. So that means I need f prime of, so -1 squared is 1 times 2, minus a -1 is 3, right? So I'm going to need f prime of 3 times -4 minus 1, which is -5. So how do I find f prime of 3? Find the slope at that point. So at 3, I don't care the values too, but that doesn't mean anything. The slope right here, I can see that it's negative, and it's negative what? -1/2. So I get -1/2 times -5 gives me +5/2. What questions you got? Okay. Number 2, we're going to let f of x equal the square root of 2x if the rate of change of f at x equals c is 4 times its rate of change at x equals 1, then c equals blank. All right, so if we're talking rate of change, in other words for rate of change is what? Slope, and that also means derivative, right? So I need f prime. So first I'm going to rewrite f of x. F of x is equal to 2x to the 1/2 power. We agree with that? So is this product rule, chain rule, quotient rule, none of the above? Chain rule. I have a function inside of a function, right? 2x is inside that square root. So when I do f prime, I do the outside first. 1/2, leave the inside alone, 2x to the negative 1/2 power times the derivative of the inside, which is 2. So that actually gives me, so this 2 and the 1/2 cancel out, and so I get 1 over the square root of 2x. Or 2x to the 1/2 power, but we're about to actually use it, so I think that that makes a little bit more sense. So it says the rate of change of f at x equals c is 4 times its rate of change at x equals 1. So I need to find f prime of c. That's equal to 1 over the square root of 2c. And f prime of 1 is 1 over the square root of 2. Which one would we multiply by 4? What's happening here? It says if the rate of change of f at x equals c, so 1 over the square root of 2c, that is 4 times the rate of change at 1. That's what you would get right there, right? Did I do that wrong? Why is it not working out? Oh, that's right. Oh, that's right. I'm just a moron. So then that means that I get, I should have done this differently. Or I should have done it in a more organized fashion. I get 1 over the square root of 2c equals 4 over the square root of 2. I was like, oh, dang, the answer is not 4 over the square root of 2. But it's not, right? What am I looking for? C. I'm looking for C. All right, does everybody understand why I multiplied that one by 4? This rate of change is 4 times this one. Okay, so now what could I do next? I can cross multiply. So this is going to give me the square root of 2 is equal to 4 square root of 2c. Divide by 4, so I get square root of 2 over 4 equals the square root of 2c. Then what would I do? Not square root it, but I'd square it. Okay, so I'm going to square both sides. I'm going to come back over here because I've run out of room. So this is going to give me 2 over what? 16, and that's going to equal 2c. Multiply by 1/2. So, well, dividing by 2 is the same as multiplying by 1/2. So I'd have 2 over 32, which is 1 over 16. Now, I went with what she said, which is fine. There's a lot of different ways to go about this. You could have squared it here and then cross-multiplied. You could cross-multiplied, then squared before you, like, there's a lot of different possibilities. One's not necessarily better than the other, but I'm just thinking if somebody else was thinking, I would have done that differently. You'll get the same answer in the end, no matter what. Okay? What questions you got? Okay. Let's see. We're going to skip over this one because we'll come back to this. We'll do this one tomorrow, but I want to get here to answer Adrita's question from earlier. So it says, given the following information, we'll probably just get a couple of these done. Find the value of the derivative of the function at x equals 3. Okay, so we're going to have to do the derivative here. So that means I'm going to have dy dx. Is this product or is this chain? Chain. Because I have a function inside of a function. So I take care of the outside first. So g prime of f of x then I multiply that by the derivative of the inside. So when I want to evaluate this at x equals 3, unfortunately, I do not get to just change this to 3. It looks like this. dy dx evaluated at x equals 3 equals g prime of 3. Is this the exact question? Oh, we'll look at that. F prime of 3. So that means this would give me g prime of, so f of 3 is 1. F prime of 3 is negative 3. So then g prime of 1 is 0 times negative 3. So that is 0. I guess I didn't even realize that they were the exact same questions. It's okay. Yeah, okay. Well, good. Then I won't feel so bad that I don't feel like we're going to get to all. There's a few extras on your homework too. All right. Well, then I don't want to rush this. So we'll come back. Remind me tomorrow. I'm going to give you some time to work tomorrow. I'll answer any other questions you have on your assignment. Remind me that we need to do number 3.